Hey guys, my name is Ethan, this is Carberra, and welcome to the series where I teach you how to analyze and visualize data in Python. Today we are actually covering quite a lot, so we're talking about line graphs, scatter plots, rug plots, and ECDF plots. So there is quite a lot to talk about, but thankfully all of these are quite simple, so I thought I'd just crush them into one video just to make things a little easier. Of course, if you find the video helpful at any point, then consider liking to let me know, and subscribing so you don't miss out on future videos in the series. But yeah, with that out of the way, let's get into it. As you can see, everything here is actually quite similar to the last episode. So we're using the same imports, we're not using anything new. So we're using Matplotlib and Seaborn as before. But instead of the live by subscribe 2021, we're actually using the data from the second half of 2020. This is just kind of a better spread of data as it has a curve in it, which is actually going to be really useful for demonstrating particularly the graphs that we're going to show off here today, which are line graph, a scatter graph, a rug graph or plot, and an ECDF plot. So we're going to go through them one by one. We're going to start with the line. We're going to start with the simplest of them all. We need to actually run the cells first. And simply put, a line graph is fig equals plt.figure, sns dot line plot. It's important to note that Seaborn doesn't really use graph anywhere in the API, it's all plots. So just keep that in mind if you're trying to think of a name for something. So data equals df, you just pass data in again. X equals day, so we're going to use the day column, and y equals views. And this will actually give me the first opportunity to show you why we've been having to convert our day column into a date time this entire time. So if I do fig.show, you'll see that turn the caps lock on now. You'll see that we just have this line graph here. So as you can see, this is where the curve was. Had quite a big curve from July to about November time. But this is just a standard run-of-the-mill line plot. You've all seen one of these before. But look down here at this x-axis. You see we have a 2020-07, 2020-08, etc., etc., etc. If we were to remove this line and run it all again, you see that one, the graph takes a lot longer to load, and two, you end up with this mess. So because it's a string or an object rather than a date time, it actually treats every single date individually, and so it tries to plot every single one on the axis, and it just becomes a complete and total mess. So having it as a date time column allows pandas, or Matplotlib specifically, I should say, to kind of use it as a scalar value. So it sees that there's a pattern. You know, it goes from one place to another rather than just all being separate entities. So yeah, that is why I've been converting it this whole time. So yeah, that's a very simple line plot. A scatter plot is really not that much different at all. So we're going to do fig equals plt.figure. That was arguably the worst misspelling I've ever made in a video. Wow, that was incredible. We're going to use the scatter plot. We are going to use slightly different data. Data equals df. So we're going to plot the correlation between views and estimated minutes watched. So along the x, we're going to have views. Along the y, we're going to have estimated minutes watched. And then we're going to do fig.show. And then it's that one. Again, I still don't have a left control key, so I'm still got a fumbling around the keyboard a bit. As you can see, this is a pretty standard scatter plot. You can see that views and estimated minutes watched are positively correlated, as you could probably imagine. But each data element has its own dot around the graph, and it looks pretty fine. But with a scatter plot, there's actually a few more options we can do. The most notable of which is the hue. So the hue, I don't really know why it's called hue. I guess because it sets the color of certain things differently. But essentially, it allows you to split the data and then show it as a different color. So we're going to do hue equals df dislikes is greater than 0. Now you can set the hue to be a column if you wanted to. So I probably could have got a second half 2020 with the subscribe dimension instead of doing this. However, you can also just pass in just a series on its own if you want to. So you can pass in a string or a pandas series. In this case, we're getting every element or every row where the number of dislikes is greater than 0. So I don't actually remember which way around this is going to go. It will tell us because it will automatically draw the legend, which is something else that Matplotlib doesn't do by default. But Seaborn will if it needs to. So greater than 0, so I think the blues are days I got 0 dislikes and oranges I got 1 or more. I'm pretty sure that's how it's going. Why is it scrolling up to the top every time? Yeah, that appears to be how it's going. It's not particularly useful in this instance because all the data is just kind of scattered randomly anyway, but you can use this to see if a particular attribute has a major effect on the points. So if there was like a huge cluster of orange over here and all the blues were like around here, you could see, oh, this particular column or particular filter has actually quite an effect on the data. The next graph I want to show you is a rug plot. And a rug plot isn't particularly useful on its own, and I'll show you for why, but it is very useful alongside particularly scatter plots actually. So we're going to be putting this against the scatter plot. But first I'm going to just show you what it actually outputs. So data equals df, the y equals views. We don't need an x at all. And seeing as we'll be doing day against views on the scatter when we bring it in, that we want the y to be views as well. And then we can do, say, our hue equals df dislikes, the same as normal, greater than 0. And then we can actually set an alpha value as well. Now, I would recommend actually setting an alpha value because this gives you an idea about clumps of data. Actually, I'll remove the alpha for now and I'll show you what I mean by that. So if we just run the... Oh, okay, that was interesting. So that's what Alt-Enter does apparently. So looking at this rug plot, we can see that it just plots all the data on one side, or I should really say along one axis. It can be along the X or the Y, it doesn't matter. But in this case, having it along the Y is more helpful. As you can see, we still have all the colors. Now, if I add an alpha, I don't know why it scrolls to the top every time, that's getting very annoying. If you add an alpha equals 0.5, and load it up, we can see that there is a degree of like fading going on. So huge clumps of data are actually more noticeable because they are brighter. It also gives you a better indication, like around here, there's like a huge mess of orange and blues. This one, I just think it's a little clearer to see what's going on, so you can see this. Yeah, it's still a mess, but it's a little bit more understandable. So I said before that it's not particularly useful on its own. Well, I am going to put the scatter plot in there as well. I don't know what all these errors are, but Matplotlib is currently using this or whatever. This doesn't happen on Windows, I'm pretty sure. But you know, it doesn't really matter that much on here. And if we do Control Enter, and then we have the scatter plot back, I've messed that up because I need to do, this needs to be day, and this needs to be views. And oh, have we not converted the data? We have. Why is that appearing like that? Have we not saved it perhaps? Oh, have we not rerun that? Maybe. Oh yeah, we probably didn't rerun the cell to convert it back. But yeah, this is basically what it looks like. So you have, say, these two blues down here. You could see a match to this, and then this orange is here. You have a blue and orange here. So anyway, it's slightly easier to work out what's going on. Probably this one here. So this blue is obviously attached to this one here. It basically just allows you to more easily see that this particular dot is 900, and this particular dot is 850. I'll probably put that up. It's just, it's like it draws a line across for it. I don't know, I just like it. I just like the rug plot personally. I don't see a reason why you wouldn't use one. Because it's just really useful. But yeah, I thought I'd show you for that reason. And the final graph that I want to show you in this video is an ECDF plot. Now, I genuinely don't remember what that means off the top of my head. I'll put a text in the video now with what ECDF actually stands for, because I don't know. But it essentially allows you to see how much of the data has been covered at a particular point. So I'm just going to quickly drawn it in, and then it'll make more sense hopefully when you actually see it. It's a bit weird to read if you're not used to it, but it is really nice. So fig dot show. See what is, oh yeah, because it's ECDF plot, not just ECDF. And then we end up with this line. So it goes from the minimum value, which is like 410-ish, all the way up to the maximum value. And on the Y, it goes from 0 to 1. And it has this proportion metric. So this graph is showing for every like number of observations, how much of the data has been covered at that point. Or more, how much of the data is below a particular point, or where the 50% mark is, etc. So we can kind of trace a line from 1,000 up to here, so this little jut here, and then we can trace this over. It's not exact, but it'll do. And, you know, it's about 0.35-ish. So about 35% of the data is below or equal to 1,000, is what we can say there, or really between 410 and 1,000. But and then we can go from, say, 0.6, so we can come across here. We get to this little jut here. It's quite useful how they all have these. And oh, this one actually seems to be going down match up pretty perfectly with 1,200. And that tells us that at 60%, we have covered all records up to 1,200 views. Or that 60% of data is less than or equal to 1,200 in terms of views. This shows that there isn't really much change in the view count. So the steeper the gradient, the more clumped together the data is. So if you remember from here, we had a lot of data clumped into like the 12 or 1,300 mark. Well, that's what this is showing off here. And this quite lenient gradient is showing that the data is actually kind of spread out. And eventually you get to the end and you have up here, you have 100% of the data is about like 1,550 or so. And it curves off and it becomes more spread out at the top. Hopefully that makes some degree of sense. There is actually another way you can use ECDF. So instead of showing proportion, you can show the count. Now, I don't actually remember if there are more than just proportion and count. I don't think so. But these are the two most useful ones anyway. And this gives you the same thing, but instead of, you know, saying that 35% of the data is below 1,000 views, we can draw a line up here. We can get to this little jut here. You can come across. You can see that about, what's in between? I don't know, maybe about 67 or 68 entries that are equal to or below 1,000 views. Or if you go to, let's say, 125, here just before this quite like really very steep gradient. And in the first 125, if we were to sort this data, in the first 125 items, there would be, we get to what, about 1,225 views or so. So it's pretty much just really a distribution graph, I suppose, that shows you kind of how dense the data is and how much of the data is in between a particular range. So it's quite nice in that respect. Of course, if you have any questions, then feel free to leave a comment below, or you can join the Discord server using the link in the description. But yeah, with that, I'd like to thank my patrons for being as incredible as they are, and I will see you next time when we talk about density graphs and histograms. So there is a lot to talk about with those two things, which is why they have a video of their own. But yeah, I'll see you for that.